Okay, so now that we have a game plan in place, let's go ahead and solve some equations with fractions in it. So we have some rational expressions here. They are, I have a monomial basically divided by monomials. And so I'm going to honor myself with the fact that we have an equal sign. And so rather than dealing with the fractions, I'm going to do some math to get rid of them. So looking at this first one, if I look at all my denominators, right, the LCD looks like it'll be, I believe, 24t. Right, everybody goes into 24, right, 8, 6, and 4, and then we need a t down there. So I'm going to take both sides of my equation, let me write it as a fraction, and I'm going to multiply both sides by 24t over 1. So there's my balancing act. When I have an equation, as long as I do the same thing to both sides, so I'm multiplying both sides by 24t, my equation still holds true. I'm mathematically in balance. Now, of course, what happens over here, the t's will divide out, leaving us with 24. Over here, we're going to distribute, and then 24 goes into 8 3 times, and so we have 3t. 6 goes into 24 4 times, so we have 4t. And then 4 goes into 24 6 times, so we have 6t. So again, I'm kind of doing those little multiplications in my head, but if you need to see it, right, you literally have 24 over t8 plus 24 over t6 plus 24 over t4, right? 8 into 24 goes in 3 times, 6 into 24 goes in 4 times, and 4 goes into 24 6 times. Fractions are cleared. That was the whole goal behind doing that. Combining like terms, I believe that this is 7 and 6, this is 13t equals 24. Divide both sides by 13, and we get our answer. So there's our solution. So using the LCD to clear the fractions. In the next one, a little bit harder to find that LCD. Perhaps we start factoring. If you need to do that, we play that trick later. But right now, there's a factor of 5x and a factor of 3, and those happen to be factors of 15x. So it looks to me like our LCD in this case is 15x. Everybody goes into that. So what do we do with that 15x? Well, we take both sides of my equation and we multiply both sides by it. So my intent is to clear those silly fractions. That equality sign gives me a lot of power. As long as I do the same thing to both sides, we're okay. And what will end up happening over here, you can see clearly the 15x's cancel out, or divide out, I should say, giving us 4. And then right here, if I do it in my head, right, 5 goes into 15 3 times, and x divided by x is gone. 3 times 2 is 6. Or if you need to see the work, this is 30x over 5x, right, minus 15x over 3. Or just in your head, 3 goes into 15 5 times, so we're left with 5x and 6 respectively. Okay, so some of you might be able to do it in your head. Others of you might literally need to write the multiplication down. And the good news is I went from an equation with fractions to one without it. And that's nice. My next balancing act would be to subtract 6 from both sides. And then divide by -5. We know that a negative divided by a negative is a positive. And so there would be our solution for problem number 2. So again, clearing out the equations, clearing out the fractions when I have an equation. It's a very, very powerful act that we can do, a balancing act. Okay, so the next one, taking a look at my denominators. Technically, the denominator here is 1, and we have an x and we have x squared. So I believe the LCD will be x squared. So how do we start solving this equation with a fraction? How about we just continue to use the same trick, and we'll multiply both sides by my LCD. All right, and the intent is to clear them. And so over here, clearly the x squares cancel out, leaving us with 8. If we distribute here, x squared times 1 is x squared. And then there's an x down in the denominator. There's 2 of them up in the numerator, and we're timesing by 2. We'll end up with plus 2x. All right, so good news is we cleared the denominator. We cleared the fractions. Bad news is we still have something to solve, and it's not as easy as these last two. These last two, we ended up with a nice linear equation to solve, but here we end up with a polynomial equation to solve, what we'll call quadratic later. So you guys remember how we solve polynomial equations? Right? What do we do there? Well, we set one side equal to 0, right? So I'll subtract 8 because what we want to use is the 0 factor property, right? So we set one side equal to 0. We factor the polynomial that we have. Again, I'm a guesser and a checker, as you guys know, and so I believe that's the right combination, right? First times first is first, last times last is last. Inner and outer give us 2x, all right? Zero factor property now says that one of these is 0, has to be. So subtracting 4, one of our answers is x equals -4. Adding 2, one of our answers, is 2. So there's our solution. Again, I forgot to mention this up here, but the idea is if you substitute these values in, right, you'll get a true statement. I'm going to trust my math. I'm going to focus on just getting the algebra done, but you could actually check them by plugging them in. So I hope you guys are getting the idea. So when we're solving an equation with fractions in it, let's find the LCD, multiply both sides by the LCD to clear the fractions, solve what's left. Sometimes it's easy with a line, sometimes we have a polynomial and we know how to do those. So last one. So again, there's technically a 1 down there. So if I take a look at my denominators, they definitely have a 3 in it and an x. So my LCD is 3x. What are we going to do with it? Well, the balancing act that we'll play is we'll take advantage of the fact that we're dealing with an equation, and as long as I do the same thing to both sides of the equation, I'm mathematically in balance. Over here, 3x times x gives us a 3x squared. If we distribute that, the 3x's in the first one will cancel out, leaving us with 4. And then in the next one, the 3's will cancel out, leaving us with an x. And again, the good news is we cleared the fractions. That was our intent. The bad news is we still have something to solve for. And so I see the x squared there. So this is a polynomial equation. So we need to set one side equal to 0. And since this is already over there, how about I just subtract 4 and add x to both sides? That'll give us 0 on that side. And putting things in descending order, we get 3x squared plus x minus 4 on the other. So we're still factoring. Again, I'm a guesser and a checker, and I believe this will be the right, oops, I think actually it's the other way around. Let's see. First times first is first, last times last is last, minus 4, yeah. So that needs to be a plus, and that needs to be a minus. There's my right combination. 0 factor property is now in play. Either the 3x plus 4 is 0, or the x minus 1 is 0. Somebody has to be 0. So over here we'll add 1, and we get x equals 1 is one of our solutions. Here we'll subtract 4 and divide by 3, and -4/3 is the other solution. So there's our introduction to solving rational expressions. We're going to keep playing the same game plan even if it gets harder. Find the LCD, multiply both sides by it to clear the fractions, and then solve the remaining equation. All right, more tougher examples coming up in some future videos.